Good evening, everyone. My name is Wahid Lutfi. Let me share my screen to show you what I have for you today, or tonight, actually. So I'm going to share my screen first. As you can see, MyWebUniversity free education videos, there's my YouTube channel. And basically, I'm tutoring you on C, C++, Python programming languages, as well as Bash scripting, as well as Unix, Windows, and many other computer science related courses. And I have a lot of videos already for you to learn from it, especially in the past few days, I've posted a number of Python data structure, Python tuple and Python list. And today topic is again Python data structure. And I'm going to just show you the presentation here, what I have for you. Let me go to a slideshow so we can get started on this session. First, we have covered already Python data structure with tuple completely. List is the first tutorial section is done. I'm covering tonight for list data structure of tutorial number 2. Then the next set would be discussed, and then a string, class, and objects, and data dictionary as time allows. And you have already seen this video on Python tuple data structure. Please watch these videos. They're very helpful. They help you for school and for work. And I want you to enhance your career as well as do great on your school projects. So a Python list data structure was covered last time. And then under the list, we say that data structure tutorial 1, list is mutable sequence, and list is we covered list slicing, conversion to tuples, set string, and sorting, and ascending or descending order, which I'm going to cover tonight as well. We barely hit the sort last time, so I'm covering that one in full details tonight. List sort in reverse versus reverse order. Sorting is different than reverse order. When you change the reverse order, the elements inside the index, or each element inside the list is not sorted. It's just the order is reversed. So we are going to discuss that as well. We covered list, extended, append, and insert differentiation between them, and then list of class and method, some of them and that are under the dir we covered under the type and getting help. So we're going to discuss tutorial number 2 tonight, which is how we can insert, remove, and pop elements, and then also the index, the length, and then the length function, the double underscore length, which is magic method or double underscore method or dunder method, we call it. All of those ones, or a Pythonic way of doing same thing that you could do, for example, for a length function. We call these ones with anything with double underscore are also called magic method or dunder method. And we are going to talk about shadow copy versus actual copy tonight. We're going to talk about sort, as I mentioned, sort whether you do it in ascending order or descending order, or sorting in reverse, and also getting a list in reverse order versus sorting in reverse order. And those are two different things. And then class object methods, whatever other class I just, when I'm talking about it, if I see something, I'll just discuss it as well. Python dir list, type list, and help list, those ones will be also shown here. So first, let me just go to a notebook, which is a Jupyter notebook from Google, and I'm going to just go to that one, just a second right here. You can see this one is https://collab.research.google.com. This website is from Google. It's a collaboration.research.google and HTTPS secure page. So that means that all your data, all the information is in secure 443 port, and it is kind of like encrypted because the HTTPS has a SSL certificate for it. So at this time, this nice notebook interface is provided by Google Research Collaboration, a website that you are just logging into this URL, and all you're doing is doing as if you're using Jupyter Notebook. And it's very nice because this one is good for student, for classes, for collaboration between your friends and co-workers. Anything you want to do it for training, for learning, you just get to use Python inside a browser. All you need is a browser, internet access, go visit to that website, it's all free. So at this time, I have already printed these 11 lines here. I'm going to just comment out this section here for all the print statement that I have here, including some other ones that are there, let's say for some of these section. Let me just comment them out, all of them first. So you only see the lines that I'm showing you for training purpose. This is going to be more clear to you rather than seeing a bigger screen with a lot of information. And by the time I explain it, it's kind of like already getting into your nerve. I don't want to do that. So at this time, as you can see, I have two lists. On line 1, I have a list called L1, which has the element as art, computer science, CSC, and math. And then the second list is L2, which is 5, integer 5, the Boolean expression true, the Boolean value true, and the Boolean value false, as well as the floating point 5.5. So if I just run this one, it doesn't do anything because I haven't done any print statement or anything. So if I want to get the value of this one, I uncomment the print L1 first. You see the list of L1 is printed here, which is the list is art, computer science, and math inside these two brackets, meaning that it is a Python list. So if I want to just know the type of this one, I could say Python type L1, and that would just say it is a list. So as you can see, it is a list, and it is good. I can do the same thing for print L2 now. So L2 is also a list, but it's having these values. As you can see, it is those values. Now I'm going to uncomment the L3 and then also do a print L3. So print L3 is just actually is going to print an empty list. But if I just do a type of those ones, print type of L2, and also print type of L3. So if I do all those three types, L1, L2, and 3, you can see they're all lists. So since we saw those ones are all lists, I'm not gonna just print that type anymore. I'm gonna remove these two lines so it is more clear to you what I want to show you. So as you can see, so for art, computer science, and math are list 1, and then 5 true, false, and 5.5 is list 2, and then the L3 is an empty list, which is this empty list has no element there. So at this time, I want to copy L1 because this one is empty. I want to just copy L1.copy to L3. And then I'm going to print it. See, once I print L3, what is going to happen here. Notice if I do this one, L3 is having those elements because I made a copy of L1 and assigned it to L3. And that L3 now is more information. Before, when I printed it, had no element. Now it's everything that was copied, like a shadow copy of L1, and assign it to L3. So I'm gonna just do L2 dot move, dot remove. So L2 dot remove, the character false, I mean the Boolean expression false, I want to remove that one. So L2 dot remove false would be the right statement here. And then at the same time, I'm going to just do L3 dot append. So when I do L2 dot remove print L2, notice if I just print L2 here, because I remove false, the L2 has everything except the false. See, 5 through 5.5. An actual one was right here, 5 through false 5.5. And this versus when I did the remove, this is the one. So I'm not gonna just do a print again here. I don't need to do this one. And then I'm going to just say, well, I removed that one. Now L3 dot append. So we're going to print L3 because we're appending L2 to it. L2 now contains 5 through and 5. And then whatever was already in the content of L3, we're appending append, add to the end of it, that one. So print L3, now L3 has the first one, which was L1, plus another list. Notice this one has bracket around it, 5 through and 5.5 is within a list. So as a nested list, a list of lists. This is just L3 dot append. We added as a this and printed that one. Now the last statement, what we are doing here, if I just remove all of these lines because no, it's okay to not, I just don't have to print them because some of them are assignment statement, we're changing the content like remove or insert. And then when we do append, we're going to just need them. So to make sure that what we make the change is there, right here is not needed. And then this for statement, we're going to just basically say for L and L3. So L3 already had this statement. So let me just do this last statement of print L3. And then you could see that when you do this, print L3, L3 has these elements, which is list 1 and list 2 appended to the end of it because of this line 6 number. And then when I'm printing it, it prints art, CSC, math 5 through and 5.5. Okay, I'm going to also show you that the difference between sorting in reverse order versus sorting it in order on this example. Let's say, for example, L1, if I just delete everything here and just have only one list. This is just one list called L1. So I could say L1.sort. And then since this is already in sorting order, let's just add biology in front of this one. Or we could just add that we're using insert method. We say L1.insert and then element 0, we're going to add biology. Biology is added. And now if I say print L1, this L1 is actually going to just show biology, art, CSC, math. Notice that biology was not in this list. Now I insert it on the first indices. If I change that one to say, send it to the end of it, I could put a -1 here and then just add it to the end of it. Notice biology is before the math, it was added. So this is not at the end of it, is -1, meaning that length of it is there. So if I just say 0, 1, 2, and if I just do it at element 2, then it might just be the right one to add. No, actually 3. Let's see, 3 is 0, 1, 2, 3. 3 would be out. Yeah, 3 is the element, the last one. So this is the length of the L1. So I could say length of L1. Let's see if we could just get that one, insert it that way also. Or L1, you could just also say L1 dot double underscore length, double underscore, and then insert it in there. That also added to the last one, biology. So many ways you can do this insert here. Since this is not in sorting order, you can see art is there, then computer science, then math, and biology. We can do a sort method. Let's do a sort method. Say we say L1 dot sort, and that simply sorted in place, we call it. Print L1, and this is already sorted in the order that we want. Art is coming here, biology, and then computer science and math. And that is in sorting order. But if I want a descending order, that was an ascending order. And then if I say L1 dot sort, we could just do here, we could just say reverse is equal true. This will just print it in reverse order. Now we're just having it in a different order. And let's print it again. Math is going to show first, computer science second, biology third, and art is there. Because alphabetical, M is before C is C, and then C is before B, and B is before A. So it's a reverse order there. And then you can also use the function sorted. So we could say print sorted. You could do it in one statement here, like this, sorted there. And then now this one will just print back in sorting order. Notice art is first in this one. And if I just do the same thing, say print, use the function sorted, and then L1 comma reverse is equal true, that sorted can take an argument whether you want to just have it in a reverse order or not. And then if you put the second argument as reverse order, this will also sort it in reverse order. So now math is C and biology. And if you look at this all picture, this is all good. I basically covered a little bit of the demo on the sort, but I will have to cover that one also, because in this documentation that I just put in notebook or notepad, and this one I just last time covered all the tutorial one, and now tonight I'm going to cover these. But we just went through the first demo. Through the first demo here we covered, I'm going to cover demo number 2, which is this one. Let's just do this one next. I'm going to copy this one, remove all of this one out, run this clean. So now you see this is empty. I'm going to paste my code here and then run it again here. Notice that this one runs everything good. So this is very easy to just show you everything while this one is there. We don't have to go and clean it up again. But notice that L3, I'm not using this one. So this L3 is extended, is not going to make sense because I have L3 not defined as empty list. So now this tilde that was there is gone. And now it is empty. L3 is empty. And then print L3 is printing this. L3 dot extend L2 is basically just getting L3 extended. And then L3 now, when we extend it, we have L3 was empty, and then 2 was in the content of it. 2 was everything that was there. We added to L3. And then L3 is basically almost, because it was empty, was a copy of L3. So we could have just, instead of doing this extend, let's see if, and instead of this statement, we could have just say L3 is equal L2. This would be actual copy of L2 is made up to L3. And then notice that L3 now has this same element that L2 has. And then when we go for the for statement for I and for L and L3, we're looking at the L3 length. If it is greater than 0, then we keep popping an element. And as we pop, we just say what element was popped, and then the L3.pop would just show the element of that was popped. And then another example I could show you is the index. Let's just see that we can find out the index of an element. Remember that example that I was showing you that I say that I'm gonna cover some more methods inside their commands, because some of the commands here that we are doing, if I just am interested in, let's say if I'm interested in, notice L1, we were not doing anything here. So I didn't need L1 to play around, but I'm going to maybe do something with L1 here. For example, we could do L1.sort, and then I think we did already that one, and then L1. And that would just show that this is in sorting order already. But if I add a PE here for physical education as a major, and then that is good enough for those one, you could see that L1.sort is just what happened here. It says that, okay, somewhere I put a comma and I forgot a string in front of the art. So that is what the problem was, and we fixed it right away. So here, when you do sort it, look, art, computer science, math, and PE is the last one. And then if I want to change the order in reverse, I say reverse is equal true. Now the same thing, math is going to be showing first. I'm sorry, PE is going to be showing first, and then math second, and CSC because it's in sorting order. And this is different than the order of L1 sub colon minus 1. Notice this one is saying that put it in reverse order, meaning that whatever it was lastly, L1. So let me just do a print here, print L1, and then right here we could say just do another print, because sometimes when you're in a notebook, you have to have a print statement, otherwise the last statement output is going to show, the other one doesn't. So this is how you get away with that one. So line 4 prints the first one, which is print in reverse order. PE is coming first, and math, and then computer science and art. But then we're just doing reverse order of the list, and the list reverse order, meaning that go back on this list, art is the last, so it's going to be printed, then computer science, then math, then PE. So notice the difference between reverse order versus sorting there. Similarly, if I say print sort L1.sort, this one is sorted. Let's just, this time we're going to do a reverse sort. Reverse is equal true. And then, so this one is reverse is equal true. And then this one, I'm going to have to do first, sorted. And then this one, if you're doing it in place, you have to do sorted, reverse is equal true, and that would not say none. But let's see why it says this time. Oh, reverse sorted requires an argument. It is not like an object method. So and then you're going to say L1 comma, and then the option that you're doing is reverse is true. So notice this one is sorted in reverse order. And if I wanted just the regular order, I could say print sorted L1. And that would be just sorting in ascending order. So it is done here. If I want to just do an end place sort, I could say L1.sort, and then do a print L1, and then also do L1.sort, and reverse is equal true, and then say print L1. Okay, so you could do that one here. This is how you do that one. Let me show you the pop method that I was covering earlier. So at this time, I'm going to have only one list, say this one, and then I'm going to say for L and L1, if last time we covered, I believe, length. Let me just see which one we covered here. We covered the double underscore length. This time I'm going to cover the length. So you can also say length of L1 greater than 0. Then say if the length of this one is there, then you're going to say print popped. Let's do popped, and then space, and then we're going to just say which element we popped. We are going to say L1 dot pop. So the L1 dot pop, when you're doing pop, it's last in, first out. So the last element, math, will be pop first, computer science second, and then art third, and this. It's like a stack, and the last in, first out. So we're going to show that one, and then let's just run it here. And now notice that popped math, then computer science, and then after that is stopped, because we have a for statement. Within the for statement, we have an if statement. We want to say while this number is greater than 0. So it doesn't stop, it does throughout this one. So you can see it pops every element of it. And at this time, if I print the last element, L1 is empty. And before that one, if I print L1 has the list of elements that we have here. Okay, so here, if I just add another element like PE, we had PE either. So let's just say bio for biology. And then we could just do those ones. You can see that the elements that are there, it is popped and everything there. Now, at the same time, while we are doing this for statement, let's just change a little bit of it. We're going to get the index of the element. So we say index. Let's use a F string. We're going to do a F string, which has this syntax, and you're going to say F string, and we're going to say L found at index of the value that we want to print. We're going to do index of L sub 0. Let's just not say found. We're going to just say this, and we're going to say sub 0 or sub 1 or something. So L dot index of L1 dot index, and then inside the index we're going to say L, because that is the object or the item that we are searching for. And then I'm going to close it with this, and then close this, and then close this, and now close this. Let's see if we get the same thing here. But notice this one is somehow growing, because it's going to get infinite loop. So I'm going to stop it. Let's just stop it here for the print statement. And then I'm going to just change this one to an F statement first. So we stop the infinite loop here, and see why. And this one went to an infinite loop, because when we say if length is greater than 0, length was already greater than 0, and then it keep doing P sub 0. And otherwise, you're going to do this. So for L and L1 at this time, it's going to be all of this. And then we are going to say PE sub 0, PE sub 1, or art is on the second one, which is this is P sub 0, sub 1, sub 2. And computer science is sub 3. And then math is sub 4. So that is correct. But why this one was going to an infinite? Because the length is greater than 0. We should have said greater than 1. And then that we stop it. But F statement took care of it, because that for statement was not going through the same loop forever. So let's just stop this one, and I'm going to show you another example here. And that is, let's see, demo 2, we did it, and let's go through demo 3. So this one, I'm gonna put this statement here also on the shadow copy on the first line. And we're going to discuss the list shadow copy versus actual copy. And notice that when I did the shadow copy, L1, which is list 1, which is this list, I want to copy that one into SC, which is shadow copy. But when I assign L1 to the actual copy, then I'm just getting the actual copy. And then right here, I'm doing two print statement to get the actual copy versus shadow copy. And then I remove false from the L1 by remove on line 7. And then I insert on the first element Python is cool. And then I put a print line to format it better. And then after the insert, I show the actual copy and shadow copy. Notice the output of this one is very nice. I'm going to explain this one again. So this is the actual copy, which is the first list one that it was just copied. Actual copy L1 has an actual copy of it. And shadow copy is like almost similar to a shadow. It is just a snapping point. It is almost like a read-only part of it. It does not get modified. As you modify the actual list, the shadow copy does not have the modification. But the actual copy, whatever changes you make to the L1, AC actual copy will have it. But on the shadow copy, whatever changes you had it at that point, and that is the only change that you have. After that, whatever change you do, like we did here on line 7, remove, that is not in the shadow copy. Or insert, that is not in the shadow copy, as you can see on the output here. So after the insert and remove, the actual copy is made, all the changes is there. Python is cool was inserted in the first element, and then art, computer science, true, and 5.5 is there, and the Boolean value false is removed. But the shadow copy is exactly what we had on the shadow copy originally. That's like a shadow copy. It's like shadow. When we move from one location to other one, our shadow gets modified with another shadow. It's not a snapping point. The previous copy is just gone, so it is no longer there. But if you copy it, shadow copy, meaning that that copy is only on memory at the time that you had it there. And then the real copy is physically our body. As we make a change, we change our clothes, we have a new clothes. As we stop in a different location, we have a different location. So that might not be a great example, but I tried. I hope you enjoyed this one. Let me just go to the next example. And the next example is demo 4. In demo 4, we already covered a number of them. So I'm going to just copy this one and then paste it here. So we save some time to not type the same print statement or less the statement that we know. And then I'm going to show you the differences. Here, when we run this one, notice that this is list 1 and this is list 2 and this is list 3. So L1.sort is going to just sort the list 1, which is already in sorting order, and it's going to write the same thing, art, CSC, and math. Then the next one, L2.sort, is basically putting false first, true second, and 5, and then 5.5 floating point last. And then the next one, L3 get extended to with L1. So this is L3 get extended with L1. L3 already had biology and physical education. L1 was added to it. But notice this extend is not like append. It puts it as a different element. It did not put it as another list. This is extending, meaning that just add another list at the end of the same, the earlier list, extend. That is the difference between extend versus append. Append was making one nested list out of two lists. Extend, it just puts elements after the first list, and then it makes L3 as a larger list, extended. So that's what does do. And that's what that one does. Print statement, we're printing here, and then L3.sort. This one, L3.sort, after we extended, we sorted, and you can see art is coming first, biology and physical education last. Computer science and math is after biology, and after computer science is math. So, and then we are doing sort and reverse order. And reverse order, physical education is coming first, math second, CC, biology, and art. And then L3.sorted, if you're doing it this way and sorted, you can see that L3.sorted is now, and this one in sorting order. And then also L3.reverse sorted. So when you assign it here versus in place, this is sorted function could just give you a new list of reverse order or and just in sorted order. So that's what line 14 and 17 is doing it. Okay, so let's get to the next one, see what we have on demo 5. On demo 5, we're going to cover a little bit, and then I think this would be the end of this session for demo 5 is covered. Once demo 5 is covered, we're going to end this session. So this one, basically, I'm having the same list. L1 is defined as this list, and L2 is defined as that one, and L3 is biology and physical education. But this time I'm showing you how the end function operator works, how the not in operator works, and other kind of else statement, if statement, and there's a lot of comparison going on here. So first we say if computer science in L1, I love computer science. So you see that it is not showing I love computer science because I purposely changed that one to CS1. Just one character off is not going to do it. Similarly, if this one is lowercase, CSC is not, it's not going to match in case sensitivity is important. So if you want the CSC to be matched, you have to type it exactly like CSC is. Now it says, I love computer science. I'm actually a computer science major. Both my bachelor and master is in computer science, and I've taught computer science classes at the university level. And I love to just practice all these kind of different programming languages. I've been in the industry for more than 30 years now, and then I have taught a lot of courses, and I have been working with a number of companies and great companies in the IT and system admin, system analysis, development, programmer, database, all kind of consulting. So I love computer science. And then here I'm just on line 8, I'm just saying if computer science not L2 or CSC not in L3, which both of the computer science is not in L2 and not in LT. So on this or statement, both of them is going to fail, then we are going to get CSC was not found N. And then here you can see I'm using the F string again. And F string, we have a placeholder L2 and another placeholder for L3 for the two lists. So the two lists are showing up here and right here. So you can put in one F string function that you could just say CSC was not found in list 1 and list 2 and list 3 or whatever you want. You just put it on that placeholder. And then here we are doing a lot of if statement. You don't do these kind of things. This is for teaching purpose. When you're writing concise code, you're going to do one if statement, an else part or something. I'm just showing you different operators that you could do, or statement. So you could also say and a statement here. So either that or that one was one case, but because CC was not found on both of them, then we are going to check it. But notice if this one is L1, the end statement is going to fail, because and is going to just say if this is not n, that is true, but this one is not an L3, that is false. So this one is true and this one is false. So false and true is going to return false, so that statement was not printed here. So if I just have a else section here and say else print anything that you want to say, let's say anything. I'm going to just show you the else part. Since this is an and statement that failed, and then it's going to come to the else part. Now we're going to get the word anything. Okay, if I change this one to or, the anything is not going to be true, because either one of those two are going to be true. This second statement on the print is executed, and then says this is not found on L1 and L2. But here, this one, I have to say that it was found. So on that or statement, when I do that one, was found, and you can say an either either L1 or L2, L3. So the thing that you're checking on L1 or L3, and this one would be accurate. Now the statement says was found in either or this and this, and you say yeah, it was found on this one, because you're listing it within the if string. Okay. I hope you enjoyed it, and please make sure you make some comments on the section where you see some improvement needed for your needs. I'll do so, and please don't forget to like and subscribe and add notes as comments, so you could see that, well, there's something that I forgot or I need to and just pay more attention to help you further. I'll do so. Have a nice one. God bless you all. Take care. Bye-bye.